Hi everyone, my name is Hassan Ali, and today I welcome you all in today's session on Introduction to Apache Spark. These slides are rather aimed to give you a very high level overview of Apache Spark, and I will try my best to explain the concepts in as simple manner as possible. So let's start. So before we come to Apache Spark, let's understand what are distributed systems and why do we actually need them. So a distributed system is actually a system whose components are located on different networked components which communicate with each other and they coordinate with each other by passing messages to one another from one system to the other. Now, the components interact with each other to achieve a common goal. Distributed systems are required for huge data computations which cannot be done by a single computer alone. The distributed systems are designed to work on huge chunks of data individually on different sets of data and communicate with each other about the results, the combined results rather. The three main challenges which we face in a distributed system are first, maintaining concurrency of components, and concurrency means the ability to execute simultaneously. The second one is overcoming the global clock. Now, having the same time for all the distributed systems is very difficult, right? So different systems might take different time to execute the same task and hence the global clock is not required. And the third challenge is managing independent failure of components. So let's say if one system fails, there should be a strategy to cover up for the failure automatically. In a distributed system setting, a problem is divided into many small tasks, and each small task is solved by one or more computers, and they communicate with each other via message in an asynchronous setting. And this is the overall idea of a distributed system. Now, the question arises, why do we need distributed systems? Now, the data is increasing day by day in terms of the volume, velocity, and variety. Almost 4 petabytes of data is produced just by Facebook every day. And every other major tech company produces enormous amount of data day in and day out. Now, this creates a need of having faster systems which can process such huge amounts of data called as the big data. This led to the development of big data processing and managing platforms like Hadoop and Spark. Talking about Apache Spark, it is an open source unified analytics engine for large scale data processing. Spark also provides an interface for programming clusters with implicit data parallelism and fault tolerance. The major advantages of using Apache Spark is first speed, second it covers different type of workloads on one system, and third it's very easy to use and work since it has APIs in it has APIs in Scala, Python and Java. So here we have some of the famous features of Apache Spark. The first one is parallel distributed computing. We all know Apache Spark as a framework is famous for its speed and its parallel computing abilities. Then the second thing is fault tolerance on commodity hardware. So fault tolerance basically means that if any one system fails, Apache Spark is able to automatically cover up for that failed system so that the entire distributed computing environment does not collapse. Then the third one is scalability. You can add more tons and tons of data and it will still work the same with not so much increase in the time that it consumes. So the third important feature is scalability. Then the most famous one is in-memory computation, which basically means that it can process data, do some kind of transformations and process whatever algorithms we want to run in memory only, which means it does not have to load all the data, it just performs in-memory computations. And then high-level APIs, which basically mean that it has very good support of programming languages, we can program and build Spark applications using Scala, Python, and Java, and which makes it very user friendly for different developers. Then, what is commodity hardware? Commodity hardware is basically any normal computer in any organization, not like any supercomputer. So we can build an Apache Spark cluster on any normal computer. Then, what are the different reasons why Spark is very famous for different data science teams? So you will see Apache Spark being used from data engineers to data scientists. Everybody has their own reasons to use them. Data scientists, they use Spark for analyzing, processing, building machine learning models in a distributed manner, while data engineers, they use Spark for building data pipelines, loading data from multiple sources, processing it, transforming it, and then loading it to further use for data scientists. So this is a good understanding of the advantages of Apache Spark and why different data science teams use Apache Spark for. So now what is an RDD? RDD is resilient distributed dataset. Why resilient? Resilient because it is able to withstand a failure quickly, which focuses on the ability of fault tolerance in Spark. Distributed because it is shared between different clusters. And dataset, but well, obviously because it has data in it. And that's why resilient distributed dataset. RDD is a fundamental data type of Apache Spark. It is distributed collection of elements. It enforces parallelization across clusters, and it is primary Spark's abstraction. Now there are essentially two type of operations that we can do with an RDD. The first one is transformations, which create a new data set from an existing one. The second one are actions, which return a value to the driver program after running a computation on the data set. So transformations and actions. Now there is something known as lazy evaluation which is associated with an RDD, which we will cover in the later slides. So RDD are immutable, which means that once an RDD is created, they cannot be modified or changed. Now if you look at the above example in the slide, we are first creating a Spark context and then loading a text file which has logs by the name of log.txt. Now what is a Spark context? A Spark context represents the connection to a Spark cluster, and it can be used to create RDDs, accumulators, and broadcast variables on the cluster. Only one Spark context should be active per JVM, and we must stop the active Spark context before creating a new one. Now, in this example, we are also creating two other variables which are errors and messages by filtering the data in lines RDD. Then we are saving those messages as error.txt. Right, so this is a simple program wherein we are loading a log file, filtering that data in the log file into errors and messages, and then saving the messages. But all of this program is executed in a very lazy manner, and it is known as lazy evaluation, which is one of the features of Spark. Now, what is lazy evaluation? Lazy evaluation means that if you tell Spark to operate on a set of data, it listens to what you ask it to do, write down some shorthand for it so it does not forget, and then does absolutely nothing. Yes, absolutely nothing. It will continue to do nothing until you ask it for the final answer. And that's when it will actually start the process of doing something. In this slide, you can see that it starts as a text file and goes through a series of transformations such as map and filter, followed by more map operations. Remember that it is this behavior that allows for fault tolerance. If a node goes offline and comes back on, all it has to do is just grab a copy of this from a neighboring node and rebuild the graph back to where it was before it went offline. The first thing that happens when you load in the text file is the data is partitioned into different blocks across the cluster, and then the rest of the process happens. So taking this forward from the previous slide, once the data is loaded in the form of an RDD, then the driver sends the code to be executed on each block. Block basically means the workers, the different components, the different systems that are there in the distributed computer, or the different clusters that are there. In the example, it would be the various transformations and actions that will be sent out to the workers. Actually, it is the executor on each worker that is going to be performing the work on each block. And you will see a bit more on the executors in the later lesson. Then the executors reads the HDFS blocks to prepare the data for the operations in parallel. After a series of transformations, you want to cache the results up until that point into the memory, and that's why a cache is created. After the first action completes, the results are sent back to the driver, and in this case, we are looking for messages that relate to MySQL or any other messages. For instance, for example, in this case that we have loaded the data, it will be these messages. This is then returned back to the driver to process for the second action. Spark will use the data on the cache. It does not need to go to the HDFS data again to load it from there. It just reads it from the cache and processes the data from there. Here we have a picture of the Spark unified stack. As you can see, the Spark core is at the center of it all. The Spark core is a general purpose system providing scheduling, distributing, and monitoring of the applications across the cluster. Then you have the components on top of the core that are designed to interoperate closely, letting the users combine them, just like they would any libraries in a software project. The benefit of such a stack is that all the higher layer components will inherit the improvements made at the lower layers. A small example, optimization to the Spark core will speed up SQL, the streaming, the machine learning, and also the graph processing libraries as well. The Spark core is designed to scale up from 1 to 1000 of nodes. It can run over a variety of cluster managers, including Hadoop, Yarn, and Apache Mesos. Or simply, it can even run on a standalone with its own built-in scheduler. Spark SQL is designed to work with the Spark via SQL and HiveQL, which is a variant of Hive SQL. Spark SQL allows developers to intermix SQL with Spark's programming language supported by Python, Scala, and Java. Spark Streaming provides processing of live streams of data. The Spark Streaming API closely matches that of the Spark's core API, making it easy for developers to move between applications that process data stored in memory versus arriving in real time. It also provides the same degree of fault tolerance, throughput, and scalability that the Spark core provides. Machine Learning MLlib is the machine learning library that provides multiple types of machine learning algorithms. All of these algorithms are designed to scale out across the cluster as well. GraphX is a graph processing library with APIs to manipulate graphs and performing graph parallel computings. So this was all about the stack, Spark Unified Stack. Coming to Spark SQL and data frame, Spark SQL blurs the line between an RDD and a relational table. It offers much tighter integration between relational and procedural processing. It does that through declarative data frame APIs, which integrates with Spark code. It also provides higher optimization. Data frame API and datasets API are the ways to interact with Spark SQL. With Spark SQL, Apache Spark is accessible to more users and it improves optimization for the current ones. Spark SQL provides a data frame API which performs relational operations on both external data sources as well as Spark's built-in distributed collections. It introduces an extensible optimizer called Catalyst as it helps in supporting a wide range of data sources and algorithms in big data. Spark runs both on Windows as well as Unix-like systems like Microsoft, macOS, Linux. It is easy to run locally on one machine. All you need is to have a Java in your system path or Java home environment variable pointing to a Java installation. Spark SQL has the following four main libraries which are used to interact with the relational and procedural processing. As you can see in this diagram, there is one data source API. So data source API is basically, this is a universal API for loading and storing structured data. Then the second one is the data frame API. A data frame is a distributed collection of data organized into names and columns. It is equivalent to a relational table in SQL used for sorting data into tables. Then the third one is SQL interpreter and optimizer. SQL interpreter and optimizer is based on functional programming constructed in Scala. The fourth API is SQL Service. Now, SQL Service is the entry point for working along the structured data in Spark. It allows the creation of data frame objects as well as the execution of SQL queries. So this is all about the different powerful Spark SQL APIs that we have for working on structured data set.